Mr. Hevel, we move on to stoichiometry.
Stoichiometry, that's right, Mr. Moore. We have a great stoichiometry lab.
This is a great one.
In store.
Tried and true.
Exactly, yeah. So, Mr. Moore has written the balanced equation up here. Well, I guess maybe you should verify it's balanced. It is very tricky to balance.
Yeah, this is a tough one.
It's very tough to balance.
NaHCO3. Have I heard of that before?
Probably. It's probably sitting around your house.
Oh.
Better known as baking soda.
Yeah. Put some hydrochloric acid in a baking soda. It's the old classic chemical reaction.
That's right. You ever do the volcano reaction when you were in elementary school? Bubbles like crazy. Gee, I wonder why.
Why does it bubble? Yeah, what does this reaction make? Salt, bubbly salt, is that what it is? I see some salt there. Aqueous salt and water, and then CO2, the gas.
Yep.
Yep.
So there's our reaction.
Okay, so what are we trying to do?
Well, we're basically going to start out with some sodium bicarbonate, the baking soda. We're going to add hydrochloric acid to it until we know it's in excess. Basically, when the bubbling stops, we'll know the reaction's complete. And then we're going to heat what remains. There's going to be quite a bit of water in there because the HCl is aqueous.
Yep.
So we're going to heat it to drive off the water, and we should just be left with one product. One of the three products should just be left in the evaporating dish at the end.
Yeah, this is great. The CO2 bubbles out right away.
Yep.
And then we'll heat the water away, so we're just left with that one product.
And we should be able to, if we do some careful mass readings before and after the heating process, we should be able to do some stoichiometry.
All right. We'll be able to find a % yield of sodium chloride that we made.
Yeah, that's the ultimate goal.
So we have everything in the back?
I think we have it all up.
Oh, look at that bright sunny day too.
Yeah. Is it too bright?
I don't think so. I'll just stand over here to the side. Boy, you brought some baking soda, it looks like.
I did bring a little bit just in case we had to run a few trials.
Yeah, okay, good.
Yeah. I mean, it's only 15 pounds worth.
Yeah, okay.
Okay.
Well, we have something to snack on then when we're done with the lab.
That's right. Somewhere we got goggles sitting out, but I don't know what happened. Sorry, I should have looked for them earlier. Oh, there they are. At least they're yours.
It's fine.
Okay.
So yeah, there is a paper for this, some instructions with the beginning of a data table. It says to use about 1.5 grams or so, 1.5 to 2 grams of baking soda.
Right. But I believe we probably ought to know the mass of our evaporating dish.
Yeah, that's true.
Before we start. And we're going to have a watch glass we put over this.
Yep.
So let's get the mass of those two items.
Okay, I'm going to come over here next to you.
And of course our balance, why is the balance not reading?
Okay, we just did a restart on it.
That's right, let's see what happens. Yeah, oh, is it too heavy? Well, we may have to do it in two separate pieces, Mr. Moore.
Okay.
So there's your evaporating dish, empty.
Nuts. Okay. Got it. 84.166.
Yep. Here's our watch glass.
Yeah, we do need to mass the watch glass, don't we?
Yep, I think
64.322.
Okay.
Yep.
So now,
Yeah, we don't care about the mass of that weighing tray.
Right.
We'll just zero that out.
okay, let's see if we can get. Ooh, got carried away. Okay, it says between 1.5 and 2, so there we go.
Good enough. 1.8801 1.880 will work. Grams.
Okay. So now we're going to add that to our evaporating dish.
Mm-hmm.
And here's our hydrochloric acid. It's aqueous, right? The HCl is dissolved in water. So we're just going to gradually add the acid, and that's going to start our chemical reaction.
Ooh, that sounds like chemistry.
It does.
I'm going to come over here away from the bright light.
Okay, now we're going to add acid here until we don't have bubbling occurring anymore. Look at this, Mr. Moore. You see we got a halo.
I
on
do
here.
see that.
Should I put the watch glass over it?
Okay, after consulting on whether we should redo this thing or not, we're just going to stay with it.
We're gonna forge ahead here. Okay, there's still a little bit of bubbling going on in there, I believe.
I think we can see it a little bit. It's so
Yeah.
hard. Oh, there it goes. Yeah, it does take a little bit of acid to use up all of that baking soda.
Okay, I'm gonna swirl it again just to. Okay, I'm pretty confident all the baking soda's reacted.
Should we confirm with just a little more
You want to do a
splash
little
of
more?
HCl?
Okay, let's do that.
Yeah, so upon the addition of a little bit more HCl, there is no more bubbling happening.
So our reaction's complete.
Yep.
Okay, so basically we have salty water there.
Yes.
So now we're going to heat to drive the water out. So we'll put it over a Bunsen burner. Watch glass on.
Yeah, that watch glass is going to be very handy. You'll see as the water in here boils, it's going to be collecting on that watch glass. And I don't know if we need to record the entire length of heating.
But you probably see there's some steam coming out the evaporator.
Yeah, you can start to, it doesn't take long. Yep, you can see that. And with just a small amount of liquid in there, it doesn't take long to boil. Although I really can't see much. Is it doing anything inside there?
I can't really
I can see some condensation on the watch glass,
Mm-hmm.
the underside of it.
Yeah, it's hard to see.
Yeah, that's what that's doing. If we didn't have the watch glass on, it would be splattering all over the place, especially toward the end.
Yeah.
So I'm going to shut it off, and then we'll come back when the heating is almost done. We've let this go a couple of minutes, 3 minutes maybe,
Mm-hmm.
and it's winding down now. You can see it is bubbling vigorously. Now the instructions will say that we heat this thing until the last water to go is going to be on the watch glass. You can see that there's a drip of water that's on the watch glass, and you can hear that crackling. The water's pretty well gone now.
Right.
It's almost gone. We're going to watch that watch glass, though. That's the last thing to go dry.
Notice all the salt now that's stuck to the
Yeah.
underside of that watch glass.
Yeah, that's why we weighed the watch glass, because we knew there would be lots of salt on it at the end.
Now it's hard to see if there's still a water drop on there. At least for me it is. I want to say I still see a water drop. Probably turn the burner back up.
Yeah, with no water sitting in the evaporating, we just crank that up.
Yeah, it's important to make sure it's dry. If you stopped heating too early and there's water left, obviously that would throw off your results.
Yeah. Got that burner cranking nicely.
The best part is when students are here and doing the lab themselves,
When a group gets to weigh the watch glass in the beginning,
Yeah.
because now they're stuck.
Yep.
not that we don't take any joy in that.
Yeah, Mr. Hevel and I like to sit in the office and talk about the funny things that the
That's
students
right.
do.
That's right. It's usually a long conversation.
Yep.
Well, we'll have to let it cool a while before
Yep.
we can weigh it.
There's one too. When students don't have much experience, we've seen students turn the burner off and just grab that very hot evaporating dish and watch glass. Yeah, it doesn't look hot, but it's hot.
Yeah, it's.
I can't tell, Mr. Moore, but I don't think I see a water drop.
Yeah, I think it's pretty well dry. And even when we turn the burner off and we let it cool,
Yeah, it's still hot.
it's still going to be evaporating if there's any still left there. So we'll just go ahead and shut the camera off and come back when it's cool enough to weigh.
Yep.
Okay, so we've been waiting at least 10 minutes, I would say.
Right.
We about 10 minutes. This thing is still rather warm. Mr. Heffel says that he's going to be not holding on to it and taking too long of a visit with
Right.
it. He's going to get it right over there to
we're gonna
that.
transfer it over to the balance here.
Yep. Yeah, and of course
Can we turn it?
it overloads the balance. No, so we'll
Oh, it does. I
Uh,
forgot about that. Duh.
yeah, we'll have to do in two parts. So here is, and you can see that dry salt. That's what's left. Dish plus the salt is 85.213 grams.
Good.
Yep.
Okay, here's the evaporating
And the evaporating dish with the salt. I think that's all the data that we need.
I believe so.
We can find a percent yield now.